All right, I want to go over the answers to your Streamflow lab. Now, some of you have given this in to me last month. Some of you are still struggling on it. So I want to go over the answers. And for those that can't figure it out, where to look for the answers. So this one, first question. How did you increase the volume of the Streamflow in the experiment? This one I actually need you to watch the video to get the answer. So give me a second and we're going to watch the video. Is equal to your data table low. Alright, so we're going to use our trough. First thing we're going to do is we're going to use one hose. One hose is equal to your data table low. So we get the water going on. Okay. Alright, notice it says one hose equals the low on your data table. I am going to fast forward to the next section you need. Now, this is posted on your Google Classroom stream. Guys, that's 2.4 seconds. So that's my 5 degrees low. My 5 degrees high means I have 2 hoses. So I have twice the volume. Now if I increase my volume, I need you guys thinking back to your notes. If I increase my volume, what should happen to my velocity? You're right, the velocity should increase. So I'm going to try to get the second hose to have the same volume as... So if I'm looking at the video, how did we increase the volume of the water? You're right, we added a second hose. Back to the questions. At a 5-degree slope, what happens to the velocity of the stream when you increase the volume of the flow? So this means I'm going to look at the data for a 5-degree slope. Low, I only have half as much water flowing. High, I have twice as much. All right? So when I'm doing that, I actually need to look at the data table. So I'm looking at my 5 degrees. Low, my velocity is 37.2 centimeters per second. High, when I added that second hose, my velocity went up to what? 48.1 centimeters per second. So if I increase the volume, my velocity increased. Number 3, if volume remains the same as the slope of the stream increases, what happens to velocity? So I'm going to look at your data again. I'm going to look at the low. Low for 5 degrees, 10 degrees, and 20 degrees, and see what happens to the velocity. Five-degree low, 37.2. 10-degree low, 62.9, and 20-degree low, 81.8 centimeters per second. So as we kept the volume the same, but we increased the slope, the velocity also increased. Number 4, at a given velocity, which takes longer to move, 100 centimeters of silt or sand? So what I'm going to do is I'm going to look at the 5 degrees low. If I'm looking at the 5 degrees low, the travel time, all right, the water is moving at took 2.2 seconds to actually move through the trough. The silt took 2.3 seconds, whereas the coarse sand took 2.9 So what took the most time? The coarse sand. So the coarse sand took the most time. Number 5, as the slope increases, what happens to the rate of stream erosion? Now this one I need you thinking back to the notes. If my velocity is greater, so is my rate of erosion. So we already looked at, as I increase the slope, even if I looked at just the same volume, then my velocity increased. So if my velocity increased with a increase of slope, my erosion would increase with a rate of change of slope. Number 6, as the volume of flow increased, what happens to the rate of stream erosion? Again, when we were looking at when I had one hose for the low and 2 hoses for the high, when I increased the volume, my velocity increased. If my velocity increased, so does my rate of erosion. Number 7, what is the apparent relationship between the volume and slope of a stream and the size of the particle it can transport? Now, the larger the slope or volume, the greater my erosion, yes? The greater my erosion, the larger the size particle I can move. On your Google Stream, I had put in how to read your reference table. Right here, the relationship of transported particle size to water velocity. As my velocity increased, so does the size of the sediment that I can move. So, as the volume and or slope increases, my velocity increases. With my velocity increasing, I can carry larger particles. Number 8, explain why stream velocity may change from season to season. Now, if we looked at a normal winter for us, we would have had more snow. We had above average temperatures. We had talked in the early spring with snowmelt and regular precipitation, our volume increases. With our volume increasing, our velocity will increase. Fast forward to the summer. Let's go August. Higher temperatures, more evaporation. More evaporation, less volume. So with less volume during the summertime, my velocity will decrease. The conclusion. What effects do the slope and volume of a stream have on its velocity and ability to transport sediments? As we said already, if I increase the slope and or volume, the velocity increases. If the velocity increases, I not only can transport larger particles, but I also can transport more particles. I hope this helps going over the answers.